Good afternoon, everyone. I'm Dr. Tina Lewandowski, and we are at 2 o'clock, so we are going to go on ahead and get started. I'd like to thank you for attending our webinar today, and we have Erin Smith with us to present. Erin Smith is a PhD candidate in the Medical Nutrition Science program at the University of Kansas Medical Center. He's helped with numerous clinical trials within the Alzheimer's Disease Research Center. His PhD project is looking at the relationship between creatine, strength, and brain health. He plans to use data from the CABA trial in his dissertation. His mentors are Dr. Debra Sullivan and Dr. Matthew Taylor. A quick friendly reminder, please keep your microphones on mute, and if you have any questions during the presentation, feel free to type them in the chat. We'll also leave time at the end of the presentation for Erin to answer any questions that you have at that time. As always, we will have the recording available on our website within 24 hours. Erin, thank you so much for taking the time to present today and joining us. I'm going to go on ahead and turn it over to you.
Thank you, Tina. Give me 1 second to get my PowerPoint pulled up. Does that look good on our screen, Tina?
Yes. Yes.
Thank you. Well, thank you, Tina, for that introduction. I am very excited to be here presenting to My Alliance. So thank you to the ADRC and My Alliance for having me here. And as Tina mentioned, I am presenting on our trial that we are about to start recruitment for. So hopefully in the next week or two, once we get our last bit of supplies, we'll start recruitment and get people coming in. And the title is called Creatine to Augment Bioenergetics in Alzheimer's Disease, or CABA for short. And bioenergetics is just a fancy word for how our body utilizes energy, which is very important in the pathophysiology of Alzheimer's disease. And Dr. Matthew Taylor is the primary investigator on the trial, with Dr. Debra Sullivan, Dr. Russell Swarthout, Dr. Jeff Burns, and Dr. Young Choi as co-investigators. And getting into the outline of the presentation, so I'll give a brief background on what creatine is, how it works, where it comes from, and what it does in the body. Then we'll get into the CABA trial, why we are doing it, what we hope to
Erin, you paused for just a moment. Would you mind repeating that? You froze for just a moment there.
Oh, yeah, sure. So I'll just go ahead and restart what I said here. But so we'll go in a background on creatine, why it's important. We'll talk about what it is. We'll get into the CABA trial, why we are doing it, and what we hope to find. Then we'll get into plenty of time for questions. I should present today for about 15 minutes. So creatine is something that is found in all our bodies, and it's also found in meat and seafood primarily. And the typical American diet provides about 1 to 2 grams per creatine per day. And you can see in this table here that the best source of creatine is actually herring, but it's still about per pound of herring, you get 3 to 0.4, 0.5 grams of creatine per pound. And for beef, 2 grams of creatine per pound. So you'd have to eat a lot of meat and a lot of fish to get what the recommended amount is to get the maximize the stores in the muscle and the brain. And that leads me to my next point, is that creatine is primarily stored in the muscle. And if you do not supplement with creatine, you need about 1 to 3 grams of creatine per day to replenish those unsupplemented stores. So again, it's found in all our bodies, and it's important for energy production. And it kind of came on stage, and I think it was the 1992 Barcelona Summer Olympics, if I remember correctly. And it was used by athletes, specifically sprinters, to increase power and strength. That's kind of when it became mainstream. And the way that creatine works is it works by increasing energy production in the creatine phosphate pathway. And the creatine phosphate pathway is very active during sprinting and high power output activities. So again, sprinting, weightlifting. And the way it works is if you have more creatine stored in your muscle, you can make that pathway go a little bit longer. So perhaps you can sprint for 20 seconds rather than 15, or if you're doing a bench press, you can do an extra rep or two. So again, it increases that strength and power output. And that's important for once we start talking about Alzheimer's disease, because we see in Alzheimer's a thing called mitochondrial dysfunction. And as we know from our freshman biology classes, mitochondria is the powerhouse of the cell. So we see that slowing down, so lack of energy production. So the thought is more creatine might be able to improve some of that slowdown. And creatine is also stored in the brain, but we may need more than 5 grams per day to increase its levels. It's because we have a blood-brain barrier, which does not allow a lot of things to pass by it. So really the only way to get more creatine, one in your muscles, but probably your stores, is probably to supplement with it, because most people aren't eating pounds and pounds of meat or fish. So that's why creatine supplementation has become popular amongst athletes and other populations. So it's great that creatine is used by athletes and people in the performance world, but how does that relate to brain health? There's been a lot of studies out there in older populations and healthy populations and some other disease states showing that creatine 5 to 20 grams per day, is a lot of various supplemental protocols, has been shown to improve cognition. And this is primarily in the older population, also vegetarians, and also some studies in depression and schizophrenia that creatine may be beneficial in. And it kind of all goes back to creatine helping in that energy pathway, kind of helps us slow down in the mitochondrial slowdown. However, two rodent studies have shown that creatine supplementation can improve cognition in rodents with Alzheimer's disease. So you can actually genetically engineer a rat to have Alzheimer's disease, or a couple different models. And one of these studies showed improvements in energy production. It's not that the other study did not show improvements in energy production, it's just that it was not studied. So again, two rodent studies have showed benefit in creatine, but to date, there have been no human studies. So there's a big gap to be filled in this area, looking at creatine and Alzheimer's in humans, because that has not been studied yet. So that brings us to the objective of the CABA trial. Is we want to determine if the supplement creatine monohydrate, and creatine monohydrate is just a supplemental form of creatine, is feasible and improves symptoms in individuals with Alzheimer's disease. So that brings us to our CABA trial, what the study is and what we are doing. It's a single arm study with an 8-week intervention. And when I say single arm, what I mean is that all the participants in the study will get creatine. So it's not a randomized controlled trial. There's no placebo versus creatine. Just everyone will get creatine, and that's because it's a pilot feasibility trial. And we're looking for 20 participants with Alzheimer's disease, so 10 female and 10 male, an equal split between the biological sexes. And our main measures are going to be compliance. And the way we're going to measure compliance is we're going to do a blood draw at baseline, in the middle of the study, and the end of study, looking at blood creatine or serum creatine to see if that increases after people start taking it. We'll also be measuring cognition at the beginning and end of the study, and we're using the NIH Toolbox, which is a little cognitive battery on an iPad. If anyone's done studies here at the ARDC, they will probably have done the Toolbox before. And we're also looking at the mitochondrial function or energy production, and that can be measured peripherally in the blood. So we'll do blood draws at the beginning and the end of the study to look at mitochondrial function. Again, that powerhouse of the cell. We want to see if creatine improves energy production. And we'll also do an MRI or brain imaging to see if brain creatine stores are increased from beginning of the study at the end of the study, because that's kind of an unknown. There's been a lot of studies looking at if creatine can increase brain stores, or if it can, what's a good protocol. And one thing I didn't talk about much in how creatine works is strength. So I mentioned that creatine can increase strength. And in Alzheimer's disease, we see people have a loss of muscle function / strength during the disease. And that's probably partly because of the disease process. Just as the disease progresses, that probably affects our muscles. But additionally, there is probably an independent effect between the muscle and the brain. So probably a crosstalk. So we also want to see if creatine increases strength in Alzheimer's disease, because that could help delay the progression of disease to getting worse. So here's a figure of what I was describing earlier. So the CABA trial is going to have 5 visits total. The baseline evaluation will be done in about a week's time frame. So it'll be 2 visits, visit 1 and visit 2. And all study visits will either be at Hoagland, which is the Brain Imaging Center on KU Med's main campus, or the Landon Center on Aging. The Landon Center on Aging is super close to Hoagland. So it's nice we're going to be able to have locations so close to each other. And Landon is where we'll do all our strength testing as well as muscle imaging. And the first visit's primarily questionnaires, consent, and a couple other small things. And we'll head over to Landon to practice that leg extension testing. That's how we're measuring strength. And then visit 2, we'll do an MRI, as well as the participant will get the creatine, and will head over to Landon to actually do the ultrasound and leg extension test. And the ultrasound is how we're measuring the size of the quad. We're looking at quad size to see if that increases from beginning to end of study. Then the study starts. So the participant will leave with a bunch of creatine. They'll take 20 grams of creatine per day. So that's 10 grams scoops twice a day. And then we'll also do weekly phone calls from myself or one of the other research assistants to see how things are coming along. Then at the midway point, the mid-study evaluation at 4 weeks is where we'll come in, check in to see how things are coming. We'll do another blood draw to see if a serum creatine or blood creatine is increased. And then there will be the final 4 weeks of the study, and the participant will come in for the end of study evaluation, which is very similar to visit 1 and visit 2 done at Hoagland and Landon. So what do we hope to find with the CABA trial? It's those outcomes that I was mentioning earlier. The big thing is it's a feasibility trial. We want to see if people with Alzheimer's disease can take 20 grams of creatine per day. And then, of course, does it improve cognition? Does it improve energy production or mitochondrial function? Do brain creatine stores increase after supplementation? And does it increase strength? So we're very excited because, again, we'll be the first group to be looking at creatine in a human population to follow up on some of those rodent studies. And that leads me into what the future directions, what do I hope will happen over the next 5 to 10 years. So if we find anything interesting, which I hope and I think we will, of course, is we'll go back for more money to do bigger studies with more participants, because the more participants you can have, the more generalizability you can have with a study. And in the future, we also have to do randomized controlled trials, because again, this CABA trial is just a single arm pilot trial. So again, everyone will get the supplement creatine monohydrate, where in the future we hope to do bigger trials where it's blinded and randomized. So we'll do placebo versus creatine supplementation. So one group will get creatine and the other one will get placebo. And that was quite short, so hopefully we can fill a lot of time in here with some questions. But since the trial hasn't quite started yet, we don't have any results or anything exciting to share. I just wanted to give a very brief overview. And again, we hope to start recruitment in the next week or two. We're finalizing out the last bit of details and waiting on the last bit of supplies. And hopefully next week or the week after, we'll start calling people. And this is my contact information, both my email and my phone number. And I'm happy to answer any questions that anyone might have.
Thanks, Aaron. We appreciate your presentation and definitely would like to have you back to share the results of your study once it's wrapped up. We've got a couple questions in the chat already. Is 20 grams a lot? How much would an athlete take each day?
It is quite a bit. So typically an athlete takes about 5 grams per day. And the reason why we're doing more is because some of the evidence that is out there shows that you need more creatine to actually influence brain creatine stores. So 20 grams is quite a bit. And I didn't mention that we are doing kidney function as well as a metabolic panel on all participants. The evidence that is out there shows that 20 grams per day for many months is safe, because there have been some trials that have done 20 grams per day for, I think, 6+ months with no adverse effects on the kidneys or any other blood lab. So it is quite a bit. The only adverse event or outcome that has been shown with creatine supplementation consistently is kind of upset stomach, and that's a good amount of powder. But the good thing about creatine is it's dissolvable in fluid. So this is quite a bit more. 20 grams is quite a bit more than athletes would typically take. And that's because we want to make sure that we're influencing the brain creatine stores, because that's where we need it to see the results we're hoping to see. But great question.
Mhm. Marge has another question, or Marge has a question here. Can we buy the supplement at a drugstore or through KU? So if people just want to take the supplement on their own.
Yeah, so pretty much any major grocery store or the pharmacy will have it, and you can buy it anywhere online. It's very cheap. That's the good thing about creatine monohydrate. And I would always recommend anyone talk to their physician about any supplement that they planning on taking, even if it is safe. It's always good to keep your physician in the loop. But yes, it can be bought at any major grocery store or the pharmacy, any supplement store. I personally just buy mine online because I'm lazy, and Amazon's amazing. It just delivers it to your front door.
I do that too. Looks like we have another question, and you addressed this a little bit. What happens when taking too much of creatine supplement? And so you had mentioned upset stomach. Is that pretty much it, or is there anything else?
Pretty much it. You'll just pee it out. So I'm sure a lot of people have heard of creatinine. So creatinine is the breakdown of creatine, and it's a proxy measure for kidney function. So people who do take creatine, their creatinine levels do go up, and it's just peed out in the urine. So that is one thing that I didn't mention our screening measures here for the CABA trial. People that have who have abnormal kidney function, they will be excluded from the trial just because that's something we don't want to mess with. So if you have problems with the kidneys, creatine is something you definitely would want to talk to your physician about.
Great. Um, we've got a question. What does CABA stand for? So you mentioned it early. Would you mind repeating that?
Yeah, it's a mouthful, but it's creatine to augment bioenergetics in Alzheimer's disease, or CABA for short. And again, bioenergetics, just a fancy word for energy production.
I'm gonna stick with CABA, Erin. I'm gonna
Yes, me too.
say CABA. All right, we've got a question here from Marge, and she wants to know how much creatine is recommended for elderly non-AD people.
Yeah, so I don't know. That's it's an experimental question. The evidence that is out there ranges from 5 to 20 grams per day. So I personally would think 5 to 10 grams per day would be more than enough to one, saturate your muscles, and maybe you need more for the brain. But that's one of the questions we're trying to answer. That's why we got money to do the imaging, because it's kind of the Wild West for how much creatine you need to influence brain stores. Some evidence has been shown at 5 to 10 grams per day, and some fails to see brain creatine increase with that amount where you need more. So that's one looping back to why we chose 20 grams a day. But I would think just 5 to 10 grams per day is plenty for just general use.
Great, and I think that'll help Amy's question here. She's wanting to know for energy, the form of creatine recommended. But I think would you suggest that she talk with her doctor on
I
that
would.
one?
Yeah, yeah. I don't want to be out here recommending any supplements without a physician's consent. That's the most important thing, is your physician knows your health as well as you do, or hopefully they do at least.
Absolutely. All right. Do we have any other questions for Erin?
This is Amy. I was just wanting to know,
thanks,
I
Amy.
couldn't copy down the form that you've been repeating. It sounded kind of complicated on the
Oh
type
yeah.
of creatinine.
Yeah, it's a creatine monohydrate. And most of the products out there are going to be micronized. So what micronized means is that it's going to be dissolved better in the fluid and also absorbed better. But if you stick to, I think 90 to 95% of the creatine monohydrate out there is micronized creatine. So yeah, creatine monohydrate, and if it's mentioned micronized on it, that's great. If it doesn't, it probably still is micronized.
So micronized creatine, but I'm not getting the middle part. That's why I said I
Oh,
just didn't have it in
creatine
the chat.
monohydrate. So like
Okay.
one molecule of water.
Okay. Thank you.
You're welcome. Yeah, thanks for attending and the question.
All right. Any other questions for Erin? Okay, well, thanks everyone for your questions. And then also, Erin, thank you so much for presenting about your study. We should have in the MyLions newsletter next week, we'll have some more information about your study too. So be on the lookout for that. And we'll go on ahead and wrap up for today. We look forward to seeing everyone next Thursday at 2 o'clock for our next weekly webinar. You can look for information about that webinar in your My Alliance Monday email, or go to our website, kualzheimers.org. This presentation is recorded and will be available on our YouTube channel within 24 hours. And you can get to that recording by going to our website and navigating to weekly webinars. If you have any questions in the meantime, feel free to email us at myalliance@kumc.edu. Thanks so much, Erin, and have a great week, everyone.